Let us consider the another important article about the differential equation of SHM. The differential equation of SHM. The long form of SHM is simple harmonic motion. Okay. The question is asked in this way that deduce the differential equation of SHM, generally for 2 marks. Sometimes asked in this way that obtain the differential equation of SHM, carries 2 marks. What do we understand by the term SHM? SHM, in simple harmonic motion, in SHM, the restoring force is, in SHM, the restoring force is always directed towards mean position. Very important point. The first point that in SHM, what happens in SHM, the restoring force is always directed towards mean position, and its magnitude is directly proportional to displacement, comma, inverted comma. What do we understand by the important point about SHM? In SHM, the restoring force, it is always directed towards mean position, and its magnitude is directly proportional to displacement. Mathematically, it can be written as, we can write mathematically it can be written as, that is restoring force, that is F. F is directly proportional to displacement. X is nothing but the displacement of a particle. Rf is equal to minus kx. The negative sign indicates that force is acting in opposite direction. Okay. K with the constant of proportionality, and F, we are well familiar that F is nothing but the force, and force is called as mass into acceleration. What do we understand by force? Force is defined as mass into acceleration. So ma is equal to minus kx. Okay, this m, keep it as it is. What do we understand by this a? A is called as acceleration. A is called as acceleration. What do we understand by acceleration? Yes, acceleration is defined as change in velocity upon time. What do we understand by A? A with acceleration, and acceleration is defined as change in velocity upon time is equal to minus kx as it is. M into d by dt we are writing here, d by dt. What do we understand by this factor v? V is nothing but the velocity. And what is velocity? Velocity is defined as change in distance or change in displacement upon time is equal to minus kx as it is. Okay. So what we get? M, this d square x upon dt dt square, m into d square x by dt square is equal to minus kx. It can also be written as, or d square x upon dt square is equal to, d square x by dt square is equal to, what remains there? Minus kx. M goes to that side, it reaches to the denominator. Or d square x by dt square, take this factor here, it becomes plus k by m into x, nothing is there, is equal to 0. Here the factor k by m we are writing as omega square, omega with the angular velocity. So what it becomes? it becomes finally d square x upon dt square plus omega square x is equal to 0. This is the differential equation of SHM. What we name it as, this is the differential equation of SHM. How the question? Deduce the differential equation of SHM carries 2 marks, or in another way, obtain the differential equation of SHM. What do we understand by SHM? In SHM, the restoring force is always directed towards mean position and its magnitude is directly proportional to displacement. Mathematically, above statement can be written as restoring force is directly proportional to displacement. Rf is equal to minus kx, k be the constant of proportionality. What is this negative sign? The negative sign indicates that force is always acting in opposite direction. But what is this force? Force is nothing but mass into acceleration. So ma is equal to minus kx. This m as it is. What do we understand by this acceleration? A be the acceleration, and acceleration is defined as change in velocity upon time. That is dv by dt is equal to minus kx as it is. Again m as it is, we are focusing on d by dt. What is there? V. What is v? V be the velocity. And what is velocity? Change in displacement upon time. That is displacement upon time is called as velocity. Minus kx as it is. M factor as it is. dd. It becomes d square x. dt dt square. So m into d square x by dt square is equal to minus kx. D square x by dt square is equal to minus kx. M goes to that side. It reaches to denominator. This is to that side negative. Take it here. This minus k by m becomes plus. What we get? D square x by dt square plus k by m into x is equal to 0. Put k by m is equal to omega square. So it becomes d square x by dt square plus omega square x is equal to 0. This is the general equation of differential equation of SHM. Watch it. Now let us consider the articles sometimes carries for 1 mark, because we have the place of 1 mark in the question paper, that define linear simple harmonic motion. Define linear SHM, or in short define SHM. SHM, the long form is simple harmonic motion. Now what do we understand by SHM? Linear periodic motion or linear SHM, it is the linear periodic. What do we understand by SHM? It is the linear periodic motion of a body. It is the linear periodic motion of a body in which the first point. What happens in SHM? SHM, it is the linear periodic motion of a body in which what happens? In which a restoring force is. In which a restoring force is always. The restoring force is always directed towards. The restoring force is always directed towards mean position. The very first point. Second point, and its magnitude is its magnitude is directly proportional to. Its magnitude is directly proportional to displacement. So these are the two important points. What do we understand by linear SHM? Linear SHM, or what is SHM? It is the linear periodic motion of a body in which what happens? Restoring force is always directed towards mean position. Second point, and its magnitude is directly proportional to displacement. Mathematically can be written as that is F proportional to X, or F is equal to minus Kx. Okay. Now again important point is that define period of SHM. What do we understand by the period of SHM? The factor period, it is related to time. What is period of SHM? Time required for a particle. Time required for a particle to complete one oscillation. What do we understand by period of SHM? It is the time required for a particle to complete one oscillation is called as period of SHM. Okay, it is denoted by the factor. Yes, it is denoted by the factor capital T. Period of SHM denoted by the factor capital T. Mathematical written as T is equal to 2 pi upon omega. Okay, T is equal to 2 pi by omega. Sometimes written as T is equal to 2 pi n. Okay, it is measured in second. What do we understand by period of SHM? Time required for a body, time required for a particle, time required for an object. For what purpose? To complete one oscillation is called as period of SHM. It is generally denoted by the factor T. Mathematically written as T is equal to 2 pi by omega, or sometimes T is equal to 2 pi n, and it is measured in second. Now, what do we understand by the factor amplitude of SHM? What do we understand by the factor amplitude of SHM? Amplitude of SHM, the maximum displacement covered by a particle. The maximum displacement covered by a particle is called as amplitude of SHM. It is denoted by sometimes small a, sometimes capital A, and measured in meter. So what do we understand by amplitude of SHM? The maximum displacement covered by a particle while performing oscillation. It is called as amplitude of SHM, and it is denoted by the factor small a, sometimes capital A, and it is measured in meter in ampere system and centimeter in CGS system. Okay, now what do we understand by the term frequency of SHM? What do you understand by the term frequency of SHM? Frequency of SHM, it is nothing but the number of oscillations performed by a particle. The number of oscillations performed by a particle in 1 second. It is called as frequency of SHM. So what is frequency of SHM? It is the number of oscillations performed by a particle in 1 SHM or in 1 second. It is called as frequency of SHM, denoted by the factor it is denoted by n. Okay, written as n is equal to 1 upon t. The general formula for frequency is n is equal to 1 upon t. 1 upon t, that is frequency in another way, nothing but the reciprocal of period. See here the formula of period. T is equal to 2 pi n. Okay, and here n is nothing but 1 upon t. So frequency and period both are reciprocal to each other. Measured in, it is measured in hertz, written as Hz. So what is frequency of SHM? Number of revolution, number of rotation, number of vibration. In SHM, number of oscillations performed by a particle in 1 second. It is called as frequency of SHM. Now what do we understand by the term phase of SHM? What do we understand by the term of phase of SHM? A quantity which describes the state of oscillation. What do we understand by phase of SHM? A quantity which describes the state of oscillation is called as phase of SHM. So these are the most important definitions related to the chapter oscillation. Generally for 1 mark and 2 mark, asked number of times. Watch it carefully. Now let us consider another important article that define seconds pendulum. Define seconds pendulum. Obtain its expression for length. What is the question? Define seconds pendulum and hence obtain the expression for length of seconds pendulum. Now first of all, what do we understand by the term seconds pendulum? That will start. Seconds pendulum, a pendulum whose time period is of 2 seconds. What do we understand by seconds pendulum? A pendulum whose time period is of 2 seconds is called as, yes, it is called as seconds pendulum. The name itself tells us the time period of a pendulum. Okay, seconds pendulum, a pendulum whose time period is of 2 seconds is called as seconds pendulum. Now let us consider the general formula for period of a pendulum. And all of you are well familiar that period of pendulum represented by the formula T is equal to 2 pi under root L upon G. What is this T? T stands for period of a pendulum. L with the length of the string, G with the acceleration due to gravity. As we have already here marked out that T be the time period of a pendulum. It is of how much second? It is of 2 seconds. So put the value of T as a 2. So we can write 2 is equal to, in place of T we are keeping the value 2 is equal to 2 pi under root L upon G. Okay. On squaring we get, yes, what we get? The square of 2, it is 4. This 4 pi square. When we take the square root goes out. What remains in the bracket? L upon G. Okay. So here the factor, the number 4 cancels out. What remains there? Nothing is there. 1. So 1 is equal to pi square L upon G. Nothing is there to the denominator. 1. Taking cross product. Yes. When we take the cross product, what we get? Pi square L is equal to G. Pi square L is equal to G. Or L is equal to G by pi square. Okay. So this is the general formula. This is the formula for length of seconds pendulum. This is the general formula for length of seconds pendulum. So what we have seen here, second pendulum, a pendulum whose time period is of 2 seconds. It is called a seconds pendulum. Let us consider the general formula for period of a pendulum, that is T is equal to 2 pi under root L upon G. T be the time period of a pendulum, L be the length of the string, G be the acceleration due to gravity. Put the value of time period 2. So 2 is equal to 2 pi under root L upon G. On squaring, we get the square of 2, 4. Square of 2 pi, 4 pi square. Square root goes out. What remains? L upon G. 4 of both sides cancels here. What remains? Nothing is there. 1. 1 upon 1 is equal to pi square L upon G. Taking cross product, we get pi square L is equal to G, or L is equal to G by pi square. So this is the general formula for length of seconds pendulum. Watch it. There are some articles which also asked for 2 marks, sometimes in the form of a short note, sometimes in the form of distinguishing points related to the chapter rotational dynamics. Number of times the question is asked that explain what do we understand by the factor or by the term centripetal force. What do we understand by the term centripetal force? If we are seeing the name centripetal, it means generally made by the term center. The name itself tells us that it is made by the term center. So what do we understand by centripetal force? The force which is acting towards the center. The force which is acting towards the center is called as centripetal force. Okay, from the name itself we can write that what do we understand by centripetal force? The force which is acting towards the center is called as centripetal force. What do we understand by its properties, its main points? The very first point is that it is real force. What we can say about centripetal force, that it is the real force. Why it is called as real force? Because it have its physical existence. It have its physical existence. Another important point, that it helps to maintain uniform circular motion. Okay, centripetal force, it provides necessary centripetal force. It helps to maintain uniform circular motion. Again, what we say that it is acting along the radius. These are the important points, that centripetal force is generally acting along the radius. Okay, we can show by the simple diagram here. Let us consider the simple diagram in which O be the center, P be the point situated on the circle, R be the radius. Okay, and this arrow tells us that here the force is acting towards the center. Okay, that is nothing but the centripetal force. It is written as that is F is equal to mass into acceleration. Sometimes it is written as F is equal to mv square upon r. Also written as F is equal to mr omega square. But the main thing is that each and every time here we are representing the symbol minus. Why? Because it is the force, it is acting towards the center. It is acting towards the center. That's why the negative symbol is there. Okay. Whenever the particle is performing motion at that time in centripetal force, it is said that it does no work. Here no work can be done whenever a particle is performing uniform circular motion. We see that here. What is the property characteristic of centripetal force? The centripetal force, it helps to maintain uniform circular motion, and whenever the particle is performing uniform circular motion, at that time we can't do a work on it. It means that work done is always equal to 0. Okay, for example, yes, for example, the best example is that earth revolves revolves around the sun. Earth revolves around the sun. Why we are taking the example here? Earth is revolving around the sun. Because whenever earth is revolving around the sun, it means that the earth is performing uniform circular motion at which the speed does not vary. The speed remains constant. Why we are writing such examples? It helps to maintain centripetal force, helps to maintain uniform circular motion. Okay, and where the uniform circular motion takes place, earth revolves around the sun. Another important point, that moon revolves around the earth. Again here moon is performing uniform circular motion, and who is helping? Centripetal force. Centripetal force helps to maintain uniform circular motion. So these are the points generally asked for 2 marks, that explain what do you understand by centripetal force. Okay, so the force which is acting towards center is called a centripetal force. It is the real force. Why? Because it's a physical existence. It helps to maintain uniform circular motion. It is acting along the radius, and it is said that also. It is also said that here Newton's laws of motion. Here Newton's laws of motion obeys. What happens in centripetal force? In centripetal force, Newton's laws of motion are obeyed. Another important point, that again what we say, that here it acts as an inertial frame of reference. These are the important points. What do we understand by centripetal force? In centripetal force, Newton's laws of motion obeys, and it acts as a inertial frame of reference. Okay, so watch it. like centripetal force. Sometimes question asked in this way, that explain centrifugal force. Explain centrifugal force. So what do we understand by centrifugal force? The force which is acting, the force which is acting away from the center, the force which is acting away from the center is called as, yes, it is called as centrifugal force. We can show the diagram, that the diagram in which the force is acting away from center. Let us consider a simple diagram in which we are representing that O as a center. From the center, a point P is situated on the circle with R as a radius, and yes, here F is the force which is acting away from the center. Now, what are its properties? Its properties are that, its main point is that it is imaginary force. It is the imaginary force, the most important point. It is imaginary force, that's why it is called as, so it is called as P silent here, that is pseudo force. Why centrifugal force is called as imaginary force? Because centrifugal force is called as imaginary force because it is the pseudo force. It is called as pseudo force, that's why it is named as imaginary force. Okay, it is acting, yes, it is acting away from center, that we are observing from the diagram. It is acting away from center. Another point here, Newton's laws of motion, does not obeys. Here Newton's laws of motion does not obeys. Another important point, that here non-inertial frames of references, here non-inertial frames of references plays a role. Okay. Now mathematically we can write F is equal to, as we have seen in centripetal force, F is equal to mass into acceleration. Another formula, F is equal to, plus we are especially indicating here, plus mv square by r. Again F is equal to, again plus mr omega square. Why? Because it is acting away from the center, that's why plus we have represented here. Okay, it does not maintain uniform circular motion. Okay, centrifugal force, it does not maintain uniform circular motion. Watch it.